Hey everyone, this is going to be very new for me. I'm filming on my phone and I'm going to be filming for you a super longboard update. I'm very excited to talk about the progress that we've been making and there's some good news, there's some bad news, but the bad news I don't think is that bad. So obviously it's good to see you again. For any of you guys that don't know me, my name is Chris. I'm the CTO of Sienci Labs. And a lot of the time I've been spending recently has been on the Super Longboard project. I've got some notes so I can make sure to hit all of the points that I want to make. As you can see, I'm in our testing shop right now, and I've got a Mark II longboard with the Super Longboard setup on it. The first thing that I'm going to get to is just I'm sorry I haven't been in front of the camera in a while. I've been trying to focus a lot more on the projects that we've been doing recently and some of the growth that our team has been going through. But if you were at the Hamilton Woodworking show on the Friday, you might have seen me. So if you haven't seen our video on the Hamilton Woodworking show, be sure to check that out. It was great to see all of you guys down there. I'm going to put a link to the video down below. Everyone else had a great time there too. I will also say before I start that I'm also going to write up a lot of what I'm going to say into a blog article. So you can check out the blog article. I'll link that in the video description or what have you, so that you can go and read more about it. And you don't have to like rewatch the video per se to get information or if I miss anything. Another thing I'm going to say before I start is I've seen a lot of posts from people who are saying that they haven't heard any updates about the SLB, and that you guys clearly are not reading our blog updates. Andy's been spending time putting out updates on the SLB under a lot of the production update blogs he's been putting out. So there isn't just the single mega SLB post that exists. There's a lot of blog posts that have been put out on the Sienci Labs website. So you can always go back and check those out. I'm going to probably link them in my update post so you can go click on them there. Okay, so now I'm going to bring you up to speed a bit on the project. So just as some background, we have been working with CNC machines for a while. I don't have our existing first version board, but this is our representative of our current board. Normally you'll see them inside a control box like this next to the machine. This is just what it looks like when it's outside of the enclosure. And basically it's a very simple system. It has an Arduino that plugs into the backside here on these pins. These are the 4 motor drivers that run the 4 motors. Those are the 4 motor outputs. And then we've got a couple other miscellaneous outputs for limit switches and spindle control and stuff like that. It's quite rudimentary, and an e-stop plug-in and some buttons on the front that, from some of the feedback I've seen, not a lot of people tend to use because they put their board out of the way, which is fair to say. So when we started with this, which was back in 2019, only a year after that, we already felt the need to be moving forward on what this was offering. And at the time, we just didn't know how we wanted to approach that. And so September 2022 is around when we started on the Super Longboard project, brainstorming how we wanted to be making upgrades to this board to make all of you guys' experience better. And the reason why the board is important is because some people don't understand how much influence this has on your ability to use your CNC router. When you think about it, your motors can only do as good as your motors can do. Some people might think that motors have fixed ability, and they do to a certain degree, but actually the motor driver also has a very big impact on what the motors can do. Another aspect is making the machine, quote unquote, smarter. So if the machine can sense that something bad has happened and it can tell you that that bad thing has happened, then of course that means that you are going to be better informed about how to use your machine, and there's less guesswork involved. So basically, this is like something that has been driving me and Andy and other people on our team to think about how can we redo this. So I kind of set out to brainstorm what we would look for in a new board redesign to make our machines better. And there were kind of two things that I wanted to address that I felt were the most important. So the first one was reliability. So basically, there's a couple points under reliability. The first is that if you have had experience in the hobby CNC community, you would know that a lot of the machines, Shapeoko, X-Carve, Open Builds, Millwright, Bob CNC, like these are all guys that are running Gerbil boards. And Gerbil is an amazing firmware. It's really been what has been the springboard for all of our, mechanically focused companies to take this CNC firmware, make quite simple electronics using that firmware, and then focus on the mechanics. And that's been great. I think it has really led the development of more mechanically sound machines in the hobby CNC market. But there are inherent downsides to Gerbil. The first is that Gerbil, how it's implemented the USB communication protocol to computers, is kind of inherently not as good as it could be. Like it's not as reliable as it could be. So when people have problems with disconnections over USB with Gerbil machines, it's not the USB per se that's the problem. It is partially from the implementation of Gerbil and how they use USB. There's also a lot of rampant EMI problems inherent to the Arduino Uno electronics that are used. They're like not set up in the best way, and they are lower cost components. And so those can kind of lead to issues cropping up. The MCU, the main thinking chip that's on the Arduino Uno, that is also not up for the job. It can run okay for many CNC applications, but it really has its limitations in terms of the speed that it can run at and the processing power it has. And that creates a situation where it can really, like, we have better hardware available today for the same price. And so why not move in that direction? The second aspect that I wanted to improve on, the first was reliability. The second is there's no room to grow. The board that I'm showing you, that's as good as you can make a Gerbil board. We have every single thing that Gerbil supports on here, basically. And there's also no wow factor. The whole point of working on machines in this industry, I'm sorry this will be a bit jittery. The whole point of working on machines in this industry is to take people's feedback and see what they're looking for and start to keep pushing the line forward on what we want our machines to be able to accomplish. And it just feels like that doesn't exist for Gerbil machines. So basically, like one example, as I already gave, is that you can add extra hardware for a smoother machine experience, not just from the motor drivers, but also if the brain of the control unit can send and receive signals faster, then it can have like a longer buffer, and it can handle more fluid communication from the computer to the CNC machine and cause less problems. We can also look at supporting higher tech motor drivers. These ones kind of use simpler signals that run to them just to turn them on and off. But we can actually have a communication protocol running between the drivers and the brains, and they can talk back and forth to each other in order to run more effectively. You can also add integration for other accessories. We're trying things like dual PWM and spindle support, 4 and 5 axis support, tool length sensors when you're making tool changes, pendant options, tool changers, plasma cutting options. These are all more up for grabs. You can also get other types of communication like Ethernet, and you can start looking also at integrated computer systems like a Raspberry Pi or other like onboard computing solutions. So this leads me to where we're at now with the project. And I'm sorry that I gave you so much, I guess, background. So we currently have poured ourselves into this project. We want it to be the best it can be for you guys. And we want it to be a board that people can purchase and it will stay with them into the future. We've spent over $300,000 on this project. It's easily the most expensive project we've had to date out of everything we've developed. And despite that, I do have a Band-Aid to rip off. If you haven't read the past blog post that Annie put out, which is that the original plan, this was our first run SLB that you might have seen pictures of, is we were going to plug a Raspberry Pi, like a compute module, onto the backside here and have a built-in computer option available. Is that we had to skip over that for now. We were spreading ourselves too thin on the development. There's a lot of complex aspects going on here. We're working with a new firmware, new hardware. We're having to build in G-Sender support for that new firmware. There's just a lot of aspects going on. Now, that isn't to say that at a later date we might release a fanless PC plugin to support. This is the newest version of the board here. So no plugin for the Ras Pi, but you can plug in a fanless PC to run it alongside your machine. But for now, we just decided to kind of better streamline the work we were putting in and focus on what, I guess, making a more reasonable first step that we were more sure of ourselves on. So yeah, I'll say it doesn't mean it's not possible. We did a lot of work with it. It was looking promising, but it wasn't quite up to the point of the compute modules. We couldn't get them to like a fully seamless CNC experience. And we didn't want to put out a half-baked product. And so we kind of decided to take a step back rather than putting out something that we weren't confident with. The fact that we still have this is amazing. We will have even better ability to integrate between hardware, firmware, and software. And so we're really proud about that. You can see how much of a step up if you compare the circuitry on this board. I mean, on the top, there's basically nothing. And on the bottom, there's just the motor drivers and, you know, a little bit of circuitry up there. And compare that to this new board, which is like all of that. So there's a lot of, next level stuff going on here. And even our manufacturer that we're used to working with has, on a couple of the prototypes that we sent out, put some components on, upside down or not in the right places. There's just a lot more places that mistakes can happen. Let me see. Okay, I will say the remaining goals of the project are still intact. We don't have a finalized price, but if you want to reference what the price might be, you can check the big blog post that we made about the SLB. The plan is still to make this board fully backwards compatible. Any past longmill owner can buy this and plug it in. It has all of the same plugs even, and so it'll just be a plug and play swap with a couple firmware tweaks to make it work for your machine, and you're good to go. Everything that's on this board either matches or surpasses what all past longboards could do. So you're looking at the same, motor controls and all that other. Plus, we're expecting still to see much more inherent benefits with this board. Better motor speeds, better motor reliability, better protection against electrically noisy environments. And our testing so far is showing that the extra components that we've been working on are coming along well too. We've got different e-stop behavior that now it'll stop the machine from running, but it'll also inform the computer that you've pressed the e-stop so that the computer doesn't just keep running in the background. We've got custom programmable buttons, which I can show off here. I just kind of have a little test e-stop here, and you can see, let's say I just finished a job and I want to move the machine out of the way. I can just press the button down here to move it out of the way. And then I can just press the button here to move it back towards me. So that's pretty cool. Those buttons, you can program them to do whatever you want, which is very awesome. And we're going to be putting them on the e-stop instead of on the board, like on our previous board, so that you can have access to them wherever you place your e-stop. The full board now runs completely on its own power, so that makes it run more reliably for longer jobs and multi-day jobs. We've got tons more pins to control accessories. All these pins up here, these are all accessories up here, and I can get into what some of those are at a later date. We've got LEDs that are on here. So like for instance, if I turn on the coolant, then you can see the light down here turns on and off. Or if I were to touch the touch probe to itself, you could see on here the light that turns on and off for that. So that's something that's really cool for troubleshooting if you're not sure what's going wrong with your board. And the other thing that you might have noticed is this board enclosure, which is close to our final version that we think we're going to be putting out. The cool thing about it is it comes with a bracket that allows you to fasten it directly to the rail. It's facing away from the cutting area, so it's quite dust resistant. It's got some of the common plugs out the front you'd want, like the e-stop and the probe and the USB. The plugs out the back, like the power, Ethernet, tool length sensor, laser. And then in the rest of it's on the inside, and there's a cover that'll go over the top here to keep it all sealed up. And it also has these flanges on the front and back so that you can optionally mount the entire enclosure to any flat surface that you'd like with some wood screws, similar to our previous design. It's got little openings for wire routing, and yeah, I think it'll be suiting all the needs that all of you guys have based off the feedback that you've given. We're aiming for that enclosure to be a nice aluminum enclosure with some ends on it. Anything else? Oh, I'll also point out that the benefits that I expect the SLB to have over other boards on the market are that basically they're all the same as the reasons that we're upgrading our Gerbil board. All the flaws that Gerbil has, all the boards on the market are mostly Gerbil boards. And any boards that aren't Gerbil boards still come with their downsides. For instance, they might not have live feed overrides, which our new board will have, just like our existing Gerbil boards had. They might not have some of the customizations that we offer, or job resuming or anything like that. So, and then I think anything else that's comparable out there is probably going to be twice as expensive as what our board is going to be. And as I said, very plug and play for like a true hobbyist experience, but also great for DIY hobby CNCers because, I mean, look at all of the IO that we're sticking on this to give people customization over what they want to do with their machine. I will come out, like as we're getting more close to the release, we will come out with more information. But basically, we've got a lot of custom IO here that you can basically choose what M commands, turn on and off different inputs and outputs to control like the inputs on relays and drive circuits and stuff like that. So I think it's going to be stuff that people really like. We still have a little ways to go. We found some problems with this current version board, and so we're going to be doing another iteration and then distributing those to our existing beta testers. Once we're feeling even more confident, we'll distribute to the remaining beta testers and finish collecting feedback to make G-Sender as well as our board firmware more reliable. If any of you are interested, we're running Gerbil HAL, which is a complete redo of Gerbil and way more advanced, and I can get into explaining that maybe in the article, or I think Andy's also explained it in a past article. So because of that, we're going to be probably pushing the timeline from, we're aiming for fall or winter this year. Obviously fall is past. I think we're probably going to be aiming for spring of next year, February, March, to have the boards ready. But we're going to be talking about it more as we approach the remaining winter months of November, December, to see if we can make some sort of pre-order available to you guys or something along those lines. We want to make sure that we're doing this right. We want to make sure that we're putting out something that you guys like. So if you have any feedback, if you have any questions, if you have any concerns about what you've seen so far, I would really appreciate it if you would leave us a comment on any of the places that I post this video. And yeah, I think that if you can let us know if you're excited about it, then that would be great too. I think me and my team would really appreciate the encouragement to keep pushing along on the work that we're putting in. One thing I'm really excited about, because I'm very much an open source guy, is that once this board is done, we will be putting all the plans out to the public like we always do for all of our stuff, and all of the firmware stuff will also be publicly available. And so I'm excited to see that even though we've had to go through the effort to make this big step, that hopefully we've blazed a trail for everyone to follow. I really would like to see everyone having much more reliable and easy to use hobby CNCs for their home and their shops, and so that they can just get to making projects and just enjoy the process, right? Keep using their CNCs like a tool rather than sometimes a cause for headache. So anyway, that's it for now. I hope you are not asleep and you appreciated my ramble at least a little bit, or you put it to ×2 speed. I'll catch you guys later. I'll hit you with another update before Christmas time. And yeah, I hope you guys are all doing well. And I'll catch you later.